Right. When we talk about networking, it's not just the host. We have switches, we have routers, and many more. Together gives us the network. That's what we learned in the previous class. Now, any device that needs to be part of network, any device that needs to participate in networking need to have similar uh, language to communicate. I'm trying to put it in a simple word. Similar language to communicate. See, your laptop, the routers. If they don't talk with common language, how can they convey? In between me and your laptop, in between my laptop and your laptop, there are various devices. They all understand what I am sending. That's why they are able to send exactly the same message. They convey the same message that I have sent. Anything I speak, you understand because the network understood. After understanding, it has sent it. And on your device also, it understands what I have sent. So you are able to understand what I'm speaking. You see, I am speaking in a human language, but the machines understands in their own language, and that language between the machines, they are same. When I speak in English, not only people from India, people from various parts of the world understand because we have a common language. Likewise, every intermediate device and the end hosts, they all need to have one common language. Only then, whatever my laptop send, the intermediate devices can understand and forward it to your device, and your device can interpret into English language back to your earphones, to your speaker. That common language, we call it as Open System Interconnect, OSI. If you don't have OSI, you don't have common language to interact. I don't know what laptop you have. I have a Dell laptop. You may be having Mac or HP or Sony. But when I send a data, they all understand, though they are different make. How is that possible? Because all these devices are built by following one common language, one common approach, one common reference book called OSI. So this Open System Interconnect OSI is also called as a reference model. A reference model, a model that need to be referred while developing a device so that that device can be part of network. We call it as OSI, Open System Interconnect. So when you hear the word OSI, Open System Interconnect, this is what you should get in your mind. It is a language. It's a language that the network uses. And this language is a common language for any network device. This OSI is not only in computer, it is also followed in every network device, like router, switch. It's a standard. Standard. It's a standard that every device need to be followed in order to partake in network communication. See, I can design my own computer. If I am an electronic student, I can design my own, I can build my own computer. Easy. We can have our own design. You can also have your own computer, but they won't talk to each other. Why? Because they are built according to your own standard. My computer is built according to my standard. Your computer is built according to your standard. So all your computers can talk each other. All my computers can talk each other, but my computer and your computer can't talk because there is no common language between your computer and my computer. There is no common language. So if you see whether it is Mac OS or Windows operating system or Linux OS, they all can interact because they all have a common standard. For the user interface may be different. The Mac laptop and the Windows laptop, it's not same way they they look. The close button is on the right side for the MacBook. Sorry, left side. For the Windows, it is on the right side, and then the shutdown button is here down here for the Windows. For the Mac, it will be on the top here. The Apple icon you need to click. That is just the outer interface, user interface. User interface may look different, but behind the device architecture, they're all built by referring one common reference model called OSI, Open System Interconnect. See how many times I have repeated the introduction, the title. The reason is you should not forget what this means. You should not struggle to recall when someone asks. It should be very fresh in your mind. That's why I repeat in this many different ways. Open system interconnect is a reference model. It's a standard. It's a language. It's a design. It's a reference book. All this why I say you should be very clear of this topic. You need to know what exactly this OSI means. This is not the way that we learned in our colleges. Definitely you learned. If you are from physics or chemistry or computer science background, you would have come across this topic, OSI. There will be some small networking topic in all degrees. So this OSI, what you might have learned in colleges is this. OSI is 7 layers. What is the use? First of all, we need to know what is OSI, which I just explained you. Now, this OSI is of 7 layers. That is correct. 7 layers. Now, this 7 layer is not physical. The 7 layer is a logical explanation that explains the standard. See? So you got 7 layers. Why do we have the 7 layers? To explain us the standard. The standard using which all the devices, including your cell phone. See, with your cell phone, you go internet, right? You book cab and etc. things. So it's a part of network. Even your cell phone has got the 7 layers. But you cannot see the 7 layers by opening your cell phone or your laptop. That's why I said OSI layer, 7 layer is not physical. It is a logical separation. Logically the functions of the standard is explained in 7 steps. 7 steps. The top level is called layer 7. And this one is layer 1. You cannot call layer 7 as 1 and 1 as 7. You should not do that. You cannot call layer 1 as layer 7 or layer 7 as layer 1. Because it's a standard, industry standard. Standard need to be followed strictly. Now this layer 1 has got a name, physical layer. Layer 2, data link layer. Layer 3, anyone want to say layer 3? Network layer. Layer 4. Very good. Layer 5. Layer 6. Layer 7. Right. Thank you. I'm happy you remember. So we got the 7 layers. Physical layer to application layer. As I said, always the top layer is layer 7. You cannot call layer application layer as layer 1. You cannot call application layer as layer 1. It should be always layer 7. This is the sequence in which you should know this. Now, OSI has got the 7 layers. Actually, the 7 layer is 7 the functions that happens while sending a traffic. These are the 7 steps, preparation methods. 7 preparation methods for a packet to be an acceptable packet in the network. You see, when you're preparing something, say for example, if you're making biryani, there is a sequence. You have to follow that sequence. You should not say, I'll put the I'll put all the masala item at the last. You cannot say like that. Then biryani won't be like biryani. There is a proper procedure sequence that you should follow in order to get good dum biryani. So you cannot have transport layer first and then data link layer and then a presentation layer. That won't work. That is not the way it works. Whatever the application layer should do, that has to be done first. You see, there's a computer here. And this computer wants to talk to this computer. A wants to talk to B. So A have to do the application layer job first. And then presentation layer. And then session layer, transport layer, network layer, data link layer, physical layer. So this is the sequence. It starts from layer 7 and the preparation ends in layer 1. It has to be always like this. Layer 7 to layer 1. Sender will prepare from application layer using an application. Say for example, I want to have a class with you. What did I do? First thing, I went to my Google chat. And then what is Google Chat? It's an application layer. And then what I did when I opened Google Chat and clicked the join button, the application starts generating some traffic. This application layer is nothing but applications that interact with the network. So what happened is immediately my laptop, when I opened that Google Chat or Google Meet, that link, when I say join, it presented to the network my request. My request I made in application layer. But network, how it will understand what I want? How will a network understand what I want? So someone have to present it to the network. Someone should encode it. Someone should interpret it, saying this is a Google Meet request to join a class with these group members. So what happened to the application layer that Google Meet presented It informed the network in the network language what I want. Now, who is responsible for this presentation? The application and the Windows operating system. What is the application I was using? Google Meet. Who presented it? The Google Meet is sitting on operating system. It is the operating system presenting it to the network. Now, for every conversation, what is conversation? Interaction. For every interaction between my laptop and your laptop, there is a session needed, like an appointment. See, there is only one CPU in my laptop. If multiple services needs CPU, there is a need for session. If all at this, if all the applications in my laptop request for CPU at the same time, there will be problem. See, I am using Google Chat now, Google Meet. Same like Google Meet, if I'm also having some other application parallelly, then all cannot go and take the CPU at the same time. There should be someone to properly organize it, saying you go first, let him go next, after him you go. You know, that session time frame. Like you take an appointment with some doctor or someone, so that there won't be clash between the patients. When you take appointment and go, there is no need of wait time. You're not going to clash with other. Likewise, here also, the network devices, all devices will maintain session. See, for example, I'm saying ping www.yahoo.com. You see, I'm getting a reply. 12 millisecond, 11 millisecond. So this response have come in 12 millisecond. How do I know? The first reply, I have requested Yahoo. Hello Yahoo, are you there? I am asking. Hello Yahoo, are you there? Are you there? That's what the ping will do. It will generate an echo request. For that, I got a reply in 12 millisecond. How do I know? Someone is maintaining the session. So it knows when the request when the request was sent and when the reply came. It knows the time interval. 11 millisecond, 12 millisecond. Average time taken for one ping is 11 millisecond. You see, that's the job of session layer. Session layer maintains time so that two conversations will not get clashed. And then comes the transport layer. Once the time is fixed, okay, this is the time that packet should leave. Once the time is fixed, now the transport need to be decided. How the traffic will be moved. What should be the size of the packet? All have to be decided here. only then it can be transported. You see, if you're vacating a house, when you're moving from a rented house to your own house, or from one rented house to another rented house, you need to plan for the transport, no? You cannot take on bicycle and say, come on, let's move our house. Not possible. With bicycle, you cannot move the entire house. So you need to plan. I have a fridge, I have a cot, I need at least one lorry of this big size. And then accordingly, we go and book a lorry. So you don't need a very big lorry. At the same time, you don't want a very small cycle. So you know how big you need because you know your house items. Accordingly, you go and pick one transport, one lorry. So transport layer in networking means what? How big the data the application layer is creating. How big data the application layer has created. Can that big data go through this physical wire? Go through this physical wire. If not, what is the capacity of the physical wire? According to that, the transport layer will segment your data. You see, segmenting or big data cannot be sent in one go because the link, the wire is not that capable, not that big bandwidth. Let's assume you want to send 2 GB file, but your link is only 100 meg bandwidth. What you want to send is 2000 meg. That is what 2 GB. 2G is what? 2000 meg. You want to send 2000 meg, but your wire capacity is only 1000. Sorry, only 100. So now the transport layer only now plans for you. Transport layer only says, I am going to segment into 20 pieces. I'm going to segment this data into 20 pieces so that I can send it through this wire. You see, segmenting means this. According to the capacity of your physical layer connection, according to the capacity of your physical layer. See, the physical layer is not only the physical wire. If you are using a laptop or if you're using a cell phone, do you have a physical wire to connect to the internet? No. But you have a physical layer of OSI with Wi-Fi. That Wi-Fi is also a physical layer. That Wi-Fi adapter, no, the Wi-Fi receiver inside your cell phone, it's a physical layer. That's the layer from where the data is sent out. So whether you have a physical wire connected to your cell phone or a laptop, or you have a Wi-Fi, you will still have a physical layer. Now, according to the capacity of the physical layer, it can be physical wire or it can be wireless signal. Even the wireless radio waves have got bandwidth. According to the capacity of that bandwidth, transport layer is going to segment the huge data into multiple pieces. That's the very important responsibility of this transport layer. Now, after segmenting, it will also sequence it. You see, you have a big packet, and now transport layer has segmented it. It has cut this into multiple pieces. It has cut this into multiple pieces. Sometimes this piece will go late. Say, for example, there's a big internet in between. This piece goes like this. And this piece will go straight. So, what I'm trying to say here is, if they are not sequenced, then it is not possible to rearrange it. I repeat, internet is a big web, mesh, not mess, mesh, like a web, fiber, web. You will have multiple paths to reach the destination. Sometimes 10th piece will go first. First piece will go last. First segment will go like 10th segment. Second segment will go like 20th segment. 50th segment will come first on the receiver side. So that has to be rearranged. For that, the receiver should know in which order I have to rearrange it. For that, the sequence number is important. So transport layer not only segments, it also sequences it. Sequencing is nothing but giving number. This is 1, this is 2. So that on the receiving side, even if the 5th piece comes first, and then comes the 4th piece, and then comes the 7th piece, and then comes the 2nd piece, and then comes the 3rd piece, and then comes the 5th, 6th piece, and then comes the 1st piece. You will know to rearrange it now. Because there is a number, you will put that 1 and you will take this 2 and attach it here. You will take this 3 and put it here. No, you will rearrange it because it has got a sequence number. So segmenting is not the only thing transport layer does. It is also going to do sequencing while it is segmenting, so that the receiving device can rearrange according to the sequence. Very important function of transport layer, segmenting and sequencing. Now, there is also another 2 main responsibilities of transport layer we are going to see. Number 1, the transport layer have to decide whether to use a connection-oriented approach or connection-less approach. Connection-oriented approach, connection-less approach. What does that mean? See, you're writing a mail to someone, maybe using Gmail or Yahoo. Do you check whether the receiver is sitting with the computer or not before writing a mail? Try to answer. I'm asking question. You're writing a Gmail to me. Before writing, are you checking whether I am there to receive the mail? I have kept my mailbox open. Do you check that before writing? No, we don't. But when you're calling me in my phone, when the phone rings, someone picks, will you wait for an acknowledgement or will you simply talk? You will say hello. Why you are saying hello? Hello is not the one you planned to speak. Today, anyone you see, first word they will say is hello. That is an acknowledgement for the one who is on the other side. When you call me, I just pick and say hello, and you know my voice, and you know that it is me, that one who has picked the call. That hello becomes an acknowledgement for you. Only because of that, you are now talking the next sentence. If you don't get my hello, if you don't hear my hello, if I don't say hello or you didn't hear hello, you will not be telling what you want to tell. You will be keep saying hello again. Say for example, you want to say that it's going to be heavy rain tomorrow. You want to say this to me. Now, when you when you hear someone picking the call, but they didn't say hello, what will you do? You will be keep on saying hello. You will not deliver the actual message that you want to deliver. The actual message that you want to deliver is tomorrow there's going to be a heavy rain, but you will not deliver it because you did not get acknowledgement. You are waiting for me to say hello so that you get an acknowledgement that I'm there to hear. I'm there to hear from you. You are waiting for the acknowledgement. When the acknowledgement comes, when I say hello, then you say, sir, there's going to be a rain tomorrow. See, we have two type of communication. When you send an email, you really don't wait for my acknowledgement. You really don't check with me before sending a mail whether I'm sitting with my laptop or not. You don't check. You just send it, hoping that I will open my mail at least after 1 hour or half an hour or after 5 minutes and check your message. You're hoping that I will be checking your mail. If it is urgent, you would have not written a mail. You would have called me. If it is urgent, you would have called me in phone. Now, two type of communication. One is connectionless. The other one is connection oriented. Transport layer need to pick either this or that. One is connection oriented, TCP. The other one is connectionless, UDP. TCP stands for Transmission Control Protocol. Transmission Control Protocol. UDP is User Datagram Protocol. User Datagram Protocol. We have Transmission Control Protocol, User Datagram Protocol. Two type of transport. This is one type of transport, that is another type of transport. This is like our email. In email, you don't check whether the receiver is there or not. That is why I call it as connectionless. Connection, connectionless. UDP is connectionless. TCP is connection oriented. Connection oriented. TCP is connection oriented. UDP is connectionless. TCP is like our phone conversation. You call me, but you don't tell the actual message. You wait for the acknowledgement. You wait for my hello. Or if I'm a new person, you will ask, are you the person so and so? And when I say yes, it's me, then you will tell the message. TCP works like that. TCP, before sending a message from one computer to another computer, before sending the message from one computer to another computer, TCP will first check whether the other computer is ready to receive. It's very important. A computer wants to talk to B. What A will do, it will check whether B is available to receive. If B says, yes, yes, I am available, send, only then A will send. This type of transportation is called as TCP, connection oriented. UDP is not like that. UDP is connectionless. UDP is, if A want to send any traffic to B, it will simply send it, hoping that B will receive. A will hope that B will receive it. A will not check whether B is available or not. If UDP is a protocol, if UDP is a transport layer protocol, see, we are talking about OSI layer. In OSI layer, we are talking about transport layer. In transport layer, either this or this will be used. If you are expecting a very fast conversation, UDP will be used. Comparatively, this is faster than TCP. Right? See, if your application wants fast, then UDP will be used. If the application needs reliable communication, TCP will be used. TCP is reliable, whereas UDP is only best effort. Best effort delivery. I'm delivering it with my best, hoping that someone will be there to receive. It's a best effort delivery. TCP is connection oriented, so it is highly reliable. TCP, it checks for the receiver and then only it sends. That's why it is reliable. That is the same reason why it is slow also. First it will check, hello, are you there? It will ask, and the other end guy should say, yes, 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 I'm hearing you. And then only it will deliver the message. That's why it is slow. Whereas UDP will never do that check, so it is faster. TCP will do the check very often. TCP will not check only in the beginning. Every now and then it will stop the conversation and it will check whether the receiver is there or not. Why? Because it has to be a reliable communication. For reliable communication, you should ping once in a while so that the sender will know the receiver is still there to receive. But that slows down the conversation. Good news is reliable. Bad news is slower. Whereas UDP, it is faster, but the good news is faster. Bad news is it is only best effort delivery, not guaranteed delivery. This is guaranteed. This is unreliable. You cannot guarantee that packet has been delivered because this is just best effort. It won't check whether the receiver is there or not. It is best effort. It is hoping that the receiver is there. Simply hoping. Never verifies. You say TCP or UDP. Any one only can be the protocol for communication. It depends on what application needs the service. You see, in application layer, if you are doing some file transfer, then transport layer will pick TCP. It will pick TCP. Example I'll write here. Example FTP. File transfer protocol, telnet. Telnet means what? Remotely logging into some device. We'll talk about those things in detail later. Now, FTP, Telnet, SSH, HTTP, good, HTTPS, all this will use TCP. Why? Because there we need guaranteed, reliable communication. Wherever you need fast, for example, our class is actually using UDP. When I attach a document to you, it will be it will be TCP. When I'm sending a document, I'm using FTP to send the document, file transfer protocol. Then it will be TCP. But while I'm talking to you over this Google Meet, it needs to be fast conversation. Communication needs to be faster. Network communication should be faster for our human communication to sync. For that, the application will pick UDP as a protocol from transport layer. Transport layer is giving what? UDP. Transport layer gives UDP, not TCP, for our voice, for our video. For our voice and video, UDP will be the protocol, not the TCP. So I'll write here UDP real time protocol, RTP. This is the protocol that is used in sending voice traffic, video conferencing, what else? Live streaming. All this needs fast. I told you TCP, every now and then it will stop and check whether the receiver is there or not. That is going to slow down. That cannot be used in voice. See, while I'm talking to you, if network stops in the middle and checks whether you are there or not, what will happen to our conversation? It will get disconnected for a while. There will be break in my voice. So you cannot use TCP for live stream video conference. We can only use UDP. So both the protocols are important. Both are used. It is not TCP is good and UDP is bad. Because TCP has got the word reliable communication, you should not think that UDP is bad. UDP is unreliable, true, but still you need it. But still we need UDP. It is not reliable, but it is needed for fast conversation. If I use TCP for my voice, what will happen? Every now and then disconnection will happen. Every now and then my voice will drop. Every now and then there will be a delay in my voice. So the receiver will not be able to understand what I speak. UDP is best in such places. Yeah. So every protocol have got an option whether to choose TCP or UDP. For example, I told you here, Telnet uses TCP. Telnet cannot use UDP. Telnet will only use TCP. But RTP cannot use TCP. RTP can only use UDP. So every protocol has got its own option, its own choice. Every application layer protocol has got the choice to pick one of this, TCP or UDP, not both. I just explained you the difference between TCP and UDP. TCP is connection oriented. Why do we say connection oriented? Because it waits for acknowledgement. It will check whether the receiver is there or not. It will wait for the receiver to send an acknowledgement. Only after receiving acknowledgement, it will send the actual message. So what do we understand? TCP is reliable. So you call this as connection oriented because it is establishing the connection before sending the message. Well, how it establishes connection? By sending hello. Hello, are you there? On the other side, they should say yes, I am there. That's the connection it establishes first. Only when that connection is successfully established, the conversation begins. The conversation begins. We call this as three-way handshake. This is the topic from where we will be starting tomorrow. Three-way handshake. This is what we called as connection oriented. TCP does three-way handshake. UDP, no three-way handshake. No handshake in first place. It is just connectionless. This three-way handshake is what makes this as a connection oriented. So if someone asks you the difference between TCP and UDP, first thing you will say, transmission control protocol, user datagram protocol. Secondly, we'll say TCP is highly reliable because it is connection oriented. Whereas UDP is best effort delivery. Now, what does that connection oriented means? TCP does three-way handshake before exchanging the message. To establish connection, it does three-way handshake. What is a three-way handshake? The technical side of this three-way handshake, I'm going to start in the tomorrow's class. But let me put it in a simple way. I already told you what is this three-way handshake. What is that? Before I send a data, I say, hey, are you there? And you say, yes, I'm there. I'm here to receive you. Then I say, okay, fine. I'm also ready to send to you the data. Then you say, okay, please send. That is what three-way handshake. We'll talk about three-way handshake in our next class. And then we will continue transport layer. There is again one more point to learn about transport layer. After you learn TCP, UDP differences, there is one more point. The transport layer provides port number. We'll talk about those things in detail in next class. So today what we have learned is OSI is a reference model. Every device is designed to do these functions, 7 functions, in which the first is layer 7, application layer. That is where the data is generated. Application layer is the place where we work and generate some data for communication. And that data need to be presented to the network. So the network will understand how to handle that traffic. That is why it is called as presentation layer. Session layer provides the time so that one conversation won't conflict with the other. Transport layer segments the data and sequence it according to the capacity, and then uses any one of these protocol TCP or UDP depending on the application. Any question on what you have learned today? See, the presentation layer presents it to the network, meaning it changes the format. In the application layer, we use our English language. We wrote that mail or something. We generated data in our own language, human understandable language, that need to be interpreted in network language, encrypted in network language, translated in network language, and it needs to be encapsulated means covered and sent down to the session layer. The word encryption in presentation layer will sometimes confuse people. That's why I don't use that word in presentation layer. Presentation layer, though it is said it encrypts and encapsulates, actually there is no real encryption like what we used to do in VPN. VPN, that is encryption, that is ciphertext. This is not that encryption that you have in presentation layer. Here it means that from the human language, it presents the data into machine understandable language. That's what here it means. That is why it is called as presentation layer. Any other question?